Hey guys, we're continuing with our Regents review, so let's get started. Question number 11. On June 21, an observer in New York State will see the sun set. The answer is number 2, north of due west. Remember the seasons and the sunrise and sunset positions, as well as the highest point of the sun at noon for all seasons in New York. So in the summertime, if you go on your Regents review packet, page 24, in New York, the sun rises in the northeast and sets in the northwest. Its highest point is in the south. Number 12. The first S wave reaches a seismic station 22 minutes after an earthquake occurred. How long did it take the first P wave to reach the same seismic station? The correct answer is 3, 12 minutes and 0 seconds. For most of these questions, you will need to find the time difference between the P and S wave, and you need scrap paper and your reference table, page 11. You're going to go to your reference table. Now, I see that I'm given the time that the S wave reached the seismic station after the earthquake happened. I need to know how long the P wave took to get to the station. So now that I'm given my time, the travel time of the S wave from the earthquake to the station, I'm given 22 minutes. I can figure out the distance it traveled. So from 22 minutes, I go towards the side. I stop at the S wave line since we're talking about the S wave. I go down. Each small increment here is 200 kilometers, so this must be 8,800 kilometers. Both the P wave and the S wave must have traveled 8,800 kilometers to go from the earthquake to the station, but they took different times to do it. I need to figure out when the P wave, how long the P wave took to get to the station. Now that I have the distance, I can figure that out. So I can find the time difference. Actually, you can just do this. You can go back up here. So 8,800, if I go all the way up back to the P wave line and I go towards the left, I see that the P wave traveled 12 minutes to go from the earthquake to the station, and my S wave traveled 22 minutes. There's another way to do this. You can use your scrap paper. You can mark the time difference between the P and S wave. You can take it to the y-axis and see the time difference. And it looks like the P wave and the S wave time difference is 12 minutes. If the P wave took 22 minutes to arrive at the station, the S wave, the S wave took 22 minutes to arrive at the station, you should do P wave minus S wave time. So 22 minus 12 minutes, the P wave arrival must have been 12 minutes. So there are two ways to do this. This is the easier option, to just go back up and see the P wave, how long the P wave took to get to the station. Number 13, what is the minimum stream velocity necessary to transport a quartz particle that is 0.1 centimeter in diameter in a stream? The correct answer is 5 centimeters per second. When it's asking for the stream velocity, or talking about it, you should go to your reference table, page 6, the relationship of transported particle size to water velocity. It says I'm asking for, or the question is asking for, the minimum stream velocity necessary to transport a particle that is 0.1 centimeter in diameter. So particle diameter is 0.1. I go towards the right. I stop at the black line that's given to me. I go down. My minimum stream velocity is 5 centimeters per second. 14. Which two New York State locations have surface bedrock of similar ages? The correct answer is 4, Watertown and Albany. You're going to go, since we're talking about New York State and its locations, you should go to your reference table, page 3. Here's Watertown, here's Albany. Notice that they have the same type of pattern, right? Those patterns show the geological periods and eras in which the rocks are from. Looks like Watertown and Albany have the same pattern. They're both from the Ordovician period. Number 15, which factor is a primary cause of seasonal changes on Earth? The correct answer is 4, tilt of the Earth's axis. If you go to your reference Regents Review Packet, page 17, seasons are caused by the tilt of the Earth of 23.5 degrees. The map below shows 16. The map below shows two locations labeled A and B separated by a mountain range. The locations are at the same elevation. The arrows represent the direction of prevailing winds. Compared to the climate at location A, the climate at location B is most likely. The correct answer is 1, warmer and drier. If you go to your Regents Review Packet, page 15, you'll see that on the side of the ocean where the air rises, we have cooler and weather because it's raining. And on the side where the air is sinking, on the opposite side of the ocean, it will be warmer and drier, the leeward side. Number 17, the block diagram below represents surface features in the landscape region. Which diagram best represents the general stream drainage pattern of this entire region? The correct answer is 3. Here's why. You're going to go to your Regents Review Packet, page 8. You'll see all the drainage patterns for this particular type of landscape. My water will drain in this pattern. So memorize these patterns for the different shapes of landscapes. Number 18, a glacier moraine is best described as, answer is 1, unsorted sediment directly deposited by a glacier. So remember sorting. And when something is sorted, it's grouped properly by size and shape. So this is a well sorted sample. Unsorted means grouped by a mix of different sizes and shape. This is a poorly sorted sample. So if you go to your Regents Review Packet, page 8, some depositional features of glaciers are meltwater and moraine. Meltwater is sorted and moraines are unsorted. Remember, moraines are when glaciers push sediments forward and it forms a ridge of sediments. Those sediments are if sediments that are normally carried by ice are unsorted, kind of like the glacier when it's pushing. So those particles in a moraine will be unsorted. When it's meltwater, that's the water that's melting from the glacier. Water particles transported by water are normally sorted. So since it's meltwater sediments will be sorted like this. They will be grouped by size and shape, kind of like a river entering the ocean as well. Number 19, which igneous rock could physically weather to beach sand that contains the minerals pyroxene, plagioclase, feldspar, and olivine? The correct answer is 4, gabbro. We're talking about igneous rocks, so you should go to your reference table, page 6. You have the rock types, the names of the rocks, and the elements that they're made up of, the mineral composition. So I see all my options, but if you look at gabbro, gabbro is from here to here. So everything here is included in gabbro. We have plagioclase feldspar, this pattern. We have a little bit of biotite, pyroxene, and some olivine, and even some amphibole. Peridotite and dunite only have olivine and pyroxene. Granite has potassium quartz, plagioclase feldspar, biotite, and amphibole. 20. The cross-section below represents some processes of the water cycle. Arrows represent the infiltration of water. The dashed line labeled X represents the uppermost level of Earth's material that is saturated by groundwater. What is indicated by the dashed line labeled X? This is actually a water table. Remember, water table is the boundary between groundwater and land. So this would be a water table where we have groundwater and land. And that's what it looks like. The zone of saturation is where we have lots of water. The soil is saturated with water. And normally the water table, the boundary between land and the groundwater goes lower when we're pumping water from a well, kind of like this. Now, that's different from a watershed. A watershed is a river and all its tributaries draining into the ocean. So this would be a watershed. Tributaries are the branchings of the river. So these are all the different watersheds in New York. So all of these rivers and its tributaries are draining here. All of these rivers and its tributaries are draining here. FAB, and all the letters are different watersheds. And that's it. Thank you.